Hi, I want to show you how we can do quantities in an R Markdown document and have the values placed in the text so that we don't have to cut and paste values from our findings. So to do that, we're going to take a script that you're familiar with, which is the balance table function script. And notice this is the balance table function script. I've added a library command, a format table, and I've added tidyverse here, and I've updated my R version to 4.2.2, which you might want to do anyway now that it's available. It turns out that format table has been rewritten to conform with 4.2.2. So if you have an earlier version of R, it won't work with that. So remember our balance table, we can click here and we see the whole function, but we click just on this little arrow here next to it and that hides it, right, or expresses it, or we can click there and see it all and hide it. So that's our balance table function. So we're going to run the beginning here, and we got our data frame that we're simulating with the 6 variables, including a program variable. Then we run our balance table function. We get something called XX. We can just display XX here, or we can use the format table command, and we get a nice HTML formatted table. We can also use a knitter with the cable command there that generates a table, also very nice here. I'm going to delete this regression result there. So that's what we have. And now let's turn this over into a Markdown file. So we're going to go over and open a Markdown script. So a new script, Markdown. We'll just call it balance table with inline. You'll see what I mean by inline in a minute. So we go there. Here's our function. So let's first save it, and we'll just save it somewhere here. Balance table with inline. So we'll call it that, and then we'll go over and get the script. So we have our library commands in our clear environment. So I'm just going to delete those. So we'll go like this, and then we'll delete the text here from our Markdown. Then in the next code chunk, we'll create the data frame and have the function that we're creating. So that'll go there. And I think in the R Markdown, can we close it? Yeah, we can. So that works just fine in the R Markdown. And then in the last code chunk, we'll have the table, and we'll use the format table. So we won't use this one, the XX. We'll just use the format table, and I'll actually keep the hashtag, the comment there. Okay, and we'll replace that here. And let's put echo equals false into the other code chunk. And remember, you want to put warning equals false, comment equals NA. So we'll put warning equals false, and comments equals NA. And let's copy that into the other code chunk. Whoops, NA disappeared there. So there we go. So we'll just copy this into the other code chunk. And we'll delete all the text here. So let's save this, and let's go ahead and knit it. So we still haven't put anything in line, so I'll show you how to do that in a second. So we didn't put the comments equals NA and messages here in the first code chunk, so those show up. I'm not sure why this shows up down here. Very odd. Part of the format table, maybe? Oh, very strange. Let's see if that happens again. But let's include the warning equals false and comment equal NA. I think message equals false. Let's put that into the second code chunk also. All right, so now we have all the options that we need. Let's knit it again. Hopefully that'll come up cleaner. It's still giving us these ones that are in the package in the here. So I'm going to move this up to this code chunk that has the include equals false option. So let's see now if we knit that, will it suppress those messages that are coming? It's still delivering them. Don't know how to make them go away. You guys can figure that out. But we have our table here, and that's really all that we care about at the moment. It must be some other option there. So what do we want to do now? Well, we want to have some text like the mean of education for the control variable. So what we're going to do is we're going to go the mean of education for the control group in the table is, and now we're going to do an inline calculation. So we're going to have the back tick up in the upper left corner. We type R to indicate that now we're going to have some code, and we're going to calculate the mean of DF dollar education mean. And I think that's all we need for now. This isn't quite right, and you'll see why in a second. We'll put a period there. So let's knit this. Save here, and let's knit. So we should have that, I think it was 14 or something. Didn't like that. Why didn't it like that? Oh, because the data frame isn't created till after. So that's definitely a problem. We need to put this in the code chunk here. So we'll save that and knit. Right, the data frame wasn't created until the next code chunk. So of course, R had no idea how to calculate that. And there we go. I'm not sure why it's giving us, oh, we have the balance table here at the end. Yeah. So the mean of the education of 15.22. Now that's what we have here is the mean of the education for the control group and the mean of the education for the treatment group. So we need to subset the data to be just the control group, and that's program equals 0. So let's change this to be the DF education. So now we're going to use the square brackets index DF $ program equals 0. And let's save that and run and knit that. So we're calculating the mean of education in the case where the program is equal to 0. So 14.97. So we'd like to round that to 3 digits. So let's round that. So we're going to add in our text round, and we put a parenthesis, and then after the mean, we put in a comma. We tell it how many digits we want to round to, 3 digits. And now we'll go knit, and now it should be rounded to 3 digits. So it should be the same as what we have in our table. 14.77, 14.770. I wonder if we do it to 4 digits. Let's try that. See whether that gives us something different. So we're just playing with this to see the syntax. Why did that change to 15? Oh, 15.11. Is that what we got? I feel like something. Oh, it's simulating this each time. Yes, I forgot. Sorry about that. It's simulating each time. So that's why it's coming out. I was like, why is it coming out different? We didn't set a seed. So we could go here and set a seed. And when we set a seed, you can look up that command and see what it does. When we set a seed, let's go 4, 5. Now every time it'll come out, it'll give us the same randomly selected values. Not the same as what we just did, but from now on, it'll give us always the same value. So that's how we set the seed. So 14.9956, right? So I guess 4 is too many, so 3 indeed. What must have happened is the other one before was had zeros after it, so that's why it was cutting us 1 digit short, 14.996. Now we're good. Now we can see we can also just copy this and do the treatment group. So the treatment group would be program equals 1. So we'll write for the treatment group. And we can save that and knit. So once you have the syntax down once, you just need to copy and paste it and change the variable, and you can see that much easier than cutting and pasting. I prefer 2 digits here, and in the cable command also prefer 2 digits. There's no reason to have 3 digits here. Also, with this mean value, we do always want to remember to add na.rm equals true, because otherwise we'll get an error message if there are missing values. If there are missing values for the in the data set. In this case, since we simulated the data set, there's no missing values, so it'll give us exactly the same thing. No, I don't know why it's, I guess it's to 14.996 rounded to 2 digits gives us, I guess it must round up. I'm not quite sure. There's some option where we can tell it, no, we want 2 decimals. I guess 14.996, how do you round it to 2 digits? It has to be 15.00, yeah, because it's just, that's the way the number is working. Good, so that's how you can include an inline mean. You could do the standard deviation. Whatever this mean is, we could replace with standard deviation. We could replace with median and any other values that we want. And here's how we do a subset of the data. So it's the variable education subset for the observations where the program is equal to 1. Hope that's useful and maybe saves you a little time, and it's a fun thing to learn how to do and use it in